so for the first example, we have here a 1,580 kilogram car is traveling with a speed of 15 meters per second. What is the magnitude of the horizontal net force that is required to bring the car to a halt in a distance of 50 meters? So for this problem, you can observe that a force is involved. Also, there are variables from our kinematics. So this is a mixture or a combination of the two concepts. So we have the force and then our kinematics. So here we have our formula for force, that is F equal to ma, and then I will write the given. So since we cannot yet solve for the force because we do not have acceleration as a given in the problem, so we have to solve first for your acceleration. Okay, so our given is mass, that's 1,580 kilograms. Okay, so we are going to use this mass for this formula later on when we are going to solve for our force. And then in order for us to solve for the acceleration, we have your initial speed, that's 15 meters per second. Your final speed will be 0. Why 0? It's because the car is going to stop, or it is brought to a halt. Okay, and then we have your horizontal distance, that's 50 meters, and then we are going to look for your A, or your acceleration. Okay, so to solve this problem, we are going to use your table for constant acceleration. This is your table for equations of kinematics. So we are going to look for these 4 variables. It has to be present in the equation. So here we are going to use your equation number 4. Okay, you can see there we have your distance, or your x, and then we have your acceleration. We are going to find for acceleration. We have your final velocity, and then your initial velocity. So equation number 4 is equivalent to Vf squared equal to V naught squared plus 2ax. Okay, so to solve for A, we have to transpose your equation. So I will transpose your V naught to the left hand side. This is now equal to 2ax. Okay, you divide both sides by you divide both sides by 2x. Okay. So you will be left with A in this side, cancel to siya. Then your equation for A is now over 2x equal to A. Okay, and then the next step is you substitute the given. Okay, so that's 0 squared minus 15 meters per second squared over 2 times 50 meters. Okay, so calculating this using your calculator, you will get negative 2.25 meter per second squared. So don't forget your unit for acceleration, that's meter per second squared. Okay, now after getting your acceleration, we can now solve for your force. So just substitute that is F times mass, equal to mass times acceleration. So your mass is 1,580. Your acceleration, that's negative 2.25 meter per second squared. Okay, and then after multiplying the two, you will get negative 3,555 newtons. Now the negative here indicates that your force is opposing the motion of the car. Also, the negative here in your acceleration indicates that your car is decelerating, or bumagal yung takbo ng car. Okay? It is because your car is being brought to stop or to a halt. Okay? So if you're asked only for magnitude, so you get the absolute value, that's 3,555 newtons. Okay, so it could be, the question depends if you're asked for both the direction and magnitude, so you have to indicate if is it negative or positive, and then if you're only asked for magnitude, so you can just write the absolute value of your force, which is the 3,555 newtons. Okay, so for the next example we have here, a projectile is fired from the surface of the earth with a speed of 75 meters per second at an angle 35 degrees above the horizontal. If the ground is level, what is the maximum height reached by the projectile? So for the first step, you have to visualize, or you have to imagine what is happening in the problem. So here we have a projectile, so it means that we have this type of motion. So ganyan siya. And then fall siya here. So this is your ground. Sorry. Suppose that it is straight or it is level. Okay, this is where your initial speed or your 75 meters, ito yan siya. This is your initial speed. And then this is your theta or your 35 degrees. Okay? And then what we are looking for in the problem is your height. Ito yan siya. Your maximum height. Okay, or I indicated it as h. So here you can observe that the height is along your y-axis. So always yan siya nasa y-axis. That is why we are going to use for the variables with respect to y component. So here you're given is 75 meter per second, and then you have your angle, that's 35 degrees. So that's the only given in the problem. Now, to solve for this problem, we are going to solve with respect to y. So we will get your v naught y. So that's v naught sine theta. Okay, and then I will substitute that 75 meter per second sine 35 degrees. Here you will get 43.02 meter per second. Okay, so this is your initial velocity. Okay, now since we are on the y-axis, so your acceleration due to gravity is negative 9.8 meter per second squared. Now what else is the given? Okay, so after the ball is kicked, okay, pagdating ng, when the ball is at the top or at the maximum height, okay, take note that when the ball is at maximum height, your final velocity is 0. Okay, always. And then what we are looking for is your height. So your h, that is just your y equal to, I'm sorry, this is question mark. Okay, this is what we are going to look for in the problem. Okay, and now after this, you have to look for the proper or the appropriate equation to solve for this. So take note that it has to have these 4 variables, your v naught y, your final velocity, your acceleration, and then your distance or your displacement. Okay, so this is with respect to y. So we are going to use your equation number 4. Now in writing your equation number 4 with respect to y, you refer to this table. This is now vy squared is equal to v naught y squared plus 2ay and then y. So this is 2ay. Okay, and then you transpose the formula or the equation in order for us to solve for y. Okay. And then I will divide both sides by 2a para y na lang yung matira sa right hand side. Okay, so this will cancel out, and then you will be left with vy squared minus v naught y squared over 2ay equal to y. Okay, now I will substitute the values. So our vy, that's 0 squared, okay, minus 43.02 meter per second squared over 2 times negative 9.8 meter per second squared. So this is okay. And then in solving this, you will get 94.42 meters. So take note, your displacement or your y is positive. It's because yung ball is going upward siya at this point. Okay, so this is now your height, okay, or your h. Okay, and then yes. So for the last problem, have here, as a tennis ball is struck, it departs from the racket horizontally with a speed of 28 meter per second. The ball hits the court at a horizontal distance of 19.6 meters from the racket. How far above the court is the tennis ball when it leaves the racket? So here, you again visualize what is happening in the problem. So basically, it's just a tennis ball that's departing from its racket. Okay, so let's say this is your tennis ball, and then after departing the racket, it fell down, ganyan. Okay, so this is your ground. And then what we are looking for in the problem is your height. Okay, how far above the court. Okay, so ito yung hahanapin natin. And then, your horizontal speed, dito yan siya. This is your horizontal speed. So, pag ganito yung problem, your given becomes V naught x, that is 28 meter per second. And then your V naught y becomes 0. So this is for the y component, this is for the x component, and then your ax, take note your velocity here is constant with respect to your horizontal direction. So if constant speed natin or ang velocity natin, yung acceleration is equivalent to 0. Okay, and then our x is 19.6 meters. So this is the x. Okay, your distance, the distance of the ball from its original position. And then, yes, and then what else? Your ay, since it is along y-axis, your acceleration will be due to gravity, that's negative 9.8 meter per second. And then we are looking for your y. So you can observe here, tatlo lang yung variable na given. So it has to be 4 para magamit natin yung equations of kinematics natin. Now, in solving problems like this, okay, especially regardless, as long as it is in 2D or in two-dimensional motion, yung time natin along x component and y component is always the same. Okay, so ibig sabihin, yung time natin dito is equal yan siya sa time natin dito. Okay? Now here, we have a total of 4 variables na with x components. Okay? Pero sa y components, we only have 2 kasi missing pa si y and si time. Now, we are going to solve your time here para merong time dito, tapos ma-solve na natin si y. Okay? So, in solving for the time, with respect to x component, we are going to look again for the proper equation from our table of equations. Okay, so you have to have these 4 variables na naka-check dito. So it is on equation number 3. Okay, so we have your distance, your acceleration, your initial velocity, and then your time. Okay. So, your equation 3 with respect to x, that's x equal to v naught x times time plus 1/2 ax t squared. Okay? Now, from this equation, you're given a 0 variable, which is your acceleration. So, kapag i-multiply mo ito ng 0, magiging 0 to silang lahat. Okay? So, you will be left with v naught x times time. Okay, now transposing this equation you multiply both sides by 1 over v naught x para si time lang yung matira sa kabilang side. Okay? Now, your time is equivalent to x over v naught x. Okay? And then you substitute the given. That's 19.6 meters divided by 28 meter per second to get for the time. And then, your time now is equivalent to 0.7 seconds. Okay? So, ibig sabihin, this is 0.7 seconds, this is also 0.7 seconds. Okay, now we can now solve for your y, okay, or your height with respect to y component. Okay, and then again we are going to look for the equation na merong initial velocity, okay, merong acceleration, merong time, at saka merong displacement. Okay, so the same equation, that's equation 3, but with respect to y. Y equal to v naught y times plus 1/2 ay t squared. Now here, given natin, si y is, si initial velocity is 0. Ayan. Okay, and then you will be left with 1/2 ay t squared. Okay, and then you substitute the given 1/2 negative 9.8 meter per second squared times your time squared. Okay, and then you will get negative 2.401 meters. Now you can observe negative siya. Okay, it's because downward pababa na si ball. Okay, or yung tennis ball natin, it goes downward. Now, you can disregard the negative sign if you are asked for the magnitude only, so you get the absolute value, so that's 2.401 meters. Okay, so if you're asked for the displacement, you have to have the negative sign, but if you're asked only for the distance or the magnitude of the displacement, you can have it as 2.401 meters.